Guys, this is Miss Santos here, and I will be going over some of the notes that we discussed over in Zoom. One of the things that will be useful for you right now is if you take out your reference table so that you can follow along in certain activities. Today, we are discussing Table F and Table G. So, Table F is actually one of the tables we discussed right before midwinter recess, and Table F tells us if a salt will dissolve in water or not dissolve in water. It's also useful in order to predict if a substance is going to be insoluble, and therefore, if something is insoluble, it means that it will form a precipitate. One important thing to understand about Table F is that you should always pay attention to exemptions. And what I mean by exemptions is if we look at this right here and this right here, those are all your exemptions. So when we're looking at a compound like silver chloride and we use this table, I look at the back end of the compound. So here's a halide for chlorine. It says chlorine is always soluble, meaning it's going to dissolve except when combined with Ag. Because of this, that means that when Ag combines with Cl, it's not going to dissolve. So if you were to ever mix that in a beaker and you see a solid form, it's most likely Ag. So we're going to write this as insoluble. Okay? Another example is if we use, let's say, we're going to do, okay, so we're going to use calcium carbonate. So we look at the ending half of it, which is carbonate, and we look it up and we see that it's right here. But it also says, so it says it's insoluble except when combined with group 1 ions. And calcium is actually a group 2 ion. So therefore that makes this also insoluble. Another example is if we look at Ca, so calcium hydroxide, okay, CaOH2. And with CaOH2, calcium hydroxide, hydroxide is right here, which makes it insoluble. But when it's combined with calcium, that's an exception, which makes it the opposite, and it will make it soluble. So just to recap, if something is insoluble but is combined with an exception, then it's going to make it soluble. If something is soluble but then combined with something that's an exception, then it's going to make it insoluble. And that's how this table works. Another important thing to understand, and this is going to go into for table G, is different parts that make up a solution. So we learned that when we look at a compound, that it's most likely a solution if it has this symbol next to it. For example, salt water would say NaCl aqueous, which is different from NaCl S, which means just salt as a solid. Okay? And when we're looking at a solid and a solvent, so solid is a substance that's being dissolved, versus a solvent is something that is doing the dissolving. So an example would be when we make iced tea, the solute would be the powder mix, right? And then the solvent would be the water that we put the mix in to make iced tea. And another factor that's important to understand before we start discussing table G is saturation. So when we have something that is unsaturated, okay? It means that you can continue adding solute and it will continue to dissolve, and it hasn't reached the point of saturation. When we look at iced tea, okay, it's bland iced tea. That's like you didn't put enough of the sugar, right? When it's saturated, it means that you can't dissolve any more iced tea, because if you do, it's going to start to settle at the bottom. It has reached an equilibrium between solution and undissolved solute. So this is important right here, because this is something that comes up on the test. Another way to describe a saturated solution. And when we talk about iced tea, saturated is the perfect solution. Solution of iced tea. I'll put solution. Okay. Oop, spelled that wrong. But you guys know what I mean. So it means it's perfect. And when we're looking at a super saturated, I'll put super saturated. That means it's too sweet when we're looking at iced tea. And it means that it's beyond the point of saturation, meaning that you put so much sugar in it that it's starting to settle on the bottom. Okay? And we're going to look at other definitions of it. So here they show a different approach or different definition to it. And it says a solution containing the maximum amount of solute that can be dissolved at a particular solvent at a particular temperature. So when we draw this, here's a beaker. Okay. It's just gonna be like a see-through liquid. You're not gonna be able to see the sugar. This is a perfect solution here. Okay. You dissolve the maximum amount of salt that you can in this water. Nothing is settling at the bottom. You don't see any crystals. It's perfect. Unsaturated is the same way. It's just lighter. So I'm gonna put lighter. It might be lighter in color, or it might not be lighter color. You might not be able to tell. So I'm gonna scratch that out, because the lighter in color would be more for iced tea. And saturated, okay, means that you put more solute that it can be dissolved past the saturation point. So that extra stuff that you put is going to settle at the bottom, just like that. Okay. And when we are asked to describe what kind of mixtures, for saturated, it's going to be homogeneous because it looks uniform. For unsaturated, it's also going to be homogeneous, but then supersaturated is going to be heterogeneous. Okay? And that's because all these little particles start to form at the bottom. All right, so let's move on to the next slide. Just got a few more. Okay, so I'm going to highlight with this one instead. So for this one, we have the saturation line for KNO3. And it's actually this line right here, KNO3, okay? It looks a little different here. So I'm going to trace this line. Oop, I'm a little off, I'm sorry. Nope, let me erase that. No, that's not working. Okay, so I'm going to trace this line, and it's just to really explain what it is doing. So I'm off again. Okay. And I'm going to shade different areas as well of this table. Okay. So we're going to start with my line. I'm going to try to use a darker yellow so you guys can see it. So anytime you plot something and it falls on the line, the one that I highlighted in yellow, it's going to be considered saturated, okay? If it falls under the line, so I'm going to shade this whole region down here. If it falls under the line, it's going to be considered super saturated. I mean, sorry, unsaturated, meaning that you didn't dissolve enough. So we're going to write that as well. So unsaturated, okay? And if it falls above the line, so up here, now we can say it's super saturated because it is above the line. So what that means is that you put way too much. And it all depends at what temperature you're doing this, okay? Temperature is definitely something that will play a big role on this. And I'm going to write this in case some of you guys want to take a screenshot of this. So again, this is going to be changing the colors here. So it's going to be super saturated. Okay. So again, the purple area here, that's going to be unsaturated. The yellow region is saturated, and the above region is going to be super saturated. So let's see how that looks like as far as questions. So this question says, what is the solubility of NaNO3 at 50 degrees Celsius? So you are going to find NaNO3, which is this line right here. And at 50 degrees Celsius, you're going to go all the way up to the line. Okay? And that dot that I created there, you want to write how much that is. So we're going to estimate and say that that is 115 grams. Okay? So that's how much salt of NaNO3 is going to dissolve at 50 degrees Celsius, and this is an important part, in 100 grams of water. Okay? If I were to go above this line and say I put 140 instead of 115, then this is going to make my solution super saturated. Okay? So that's important to remember. On the line is saturated and it's exactly 115. If you go above it, it's going to be super saturated. For this one, NH4Cl at 90 degrees, let me change my color. So I'm going to use a pink color. So 115 grams, oh pardon me, sorry. NH4Cl, so ammonium chloride, which is this one right here. Okay, and be careful, make sure you follow the arrows. And 90 degrees Celsius, so that's up here. Okay, so that's approximately like 72. So let me get my pen. Okay, so this is approximately 72 grams. Okay, so that's what this table is telling you so far. Like how much of salt do you need to fully dissolve everything? So that way you know, okay, once I go over this point, that means it's not going to continue dissolving. But there are questions where we ask just about the saturation. So for example, for this one, it says at 50 grams at 20 degrees Celsius. So you go to 50, and I'm going to use this with let me pick a different color here. So we're going to go to 50 grams, 20 degrees Celsius, 50 grams. So you're going to plot it. So here's my plot. And we're looking at NaCl. NaCl is all the way down here. Because my dot is above the line for NaCl, this is going to be unsaturated. And if you want to talk about the mixture, you can say it's unsaturated and it is, oh, I'm so sorry. This is super saturated. I apologize. Let me erase this here. Oh, that's not erasing. There we go. So this is super saturated because it's above. Okay? And you're going to say that this is heterogeneous, okay? And to be even more specific, here's my beaker. We only needed approximately 38 grams to dissolve. Everything else is just extra. And that extra 12 grams, or the difference between what we have and what we're supposed to have, is going to settle at the bottom of your beaker. And that's my precipitate. And if you wanted to know the actual mass of it, it's going to be exactly or approximately 12 grams. Okay? When we go over the next few, so we have 50 grams of, so this next one, 50 grams of Ki at 20 degrees Celsius. So Ki is all the way up here. I'm going to change my colors here. It's all the way up here. Okay? And we want to do 50 grams. So it's the same location. It's over here. And this is way under potassium, so this is going to be unsaturated. Okay? And it's going to be homogeneous. Okay? And this last one, I'm going to use a green. Okay? This last one also says 50 and 20. So it's going to go right over here again. And we're looking at HCl. And HCl actually goes under. So this dot is above HCl. So that will make it super saturated. Okay? And it's going to be heterogeneous. Okay? I hope that makes sense. So when questions are asking you about saturation, and instead they say, how much precipitate forms? So look at the question first. So it says 50 grams of KNO3 at 50 degrees Celsius. So we're going to plot that. 50 grams, 50 degrees Celsius. Okay? And then what happens is, it says it cools down to 10 degrees Celsius. So that means it went from here to here. Because this is Celsius down here. How much precipitate forms? So if you look at KNO3, KNO3 is right here. Okay, so this is how much we need. We need approximately, let's say, 25. And I have 50. So you need to find out how much extra, which is the difference between these two dots, and that's what's going to precipitate. So we're going to do 50, because that's where my dot is, minus 25, because that's where the line is, and that gives me 25 grams. So that means in my beaker, I'm going to add 50 grams, and only 25 is going to dissolve, and the other 25 is going to settle on the bottom. We're not going to do this one because when you do 50 and 50 under HCl, it's actually unsaturated, so nothing forms. Okay. And let's look at the final one. So this last one is talking about changing in volume. So that's another one that you guys are going to sometimes see. And this one says, make sure that you understand that this says 100 grams of water. So all of this is done in 100 grams of water. So the question says the grams of KNO3 needed to fully saturate a solution at 50 degrees Celsius in 50 grams of water. So we got to use the chart first. So we do KNO3. So we need to find the mass at 50 grams of, oops, sorry. We'll do 100 grams first. 100 grams of H2O because this is 100 grams. So we go 50. So we go to 50 degrees to KNO3. So that's about 100. Oh no, it's KNO3. Sorry, went way up there. So this is like 82. So this is saying it takes 82 grams, right? Double check that. Yep. 82 grams to dissolve at 50 degrees Celsius in 100 grams of water, because that's what the graph says. But they want to know, what if I divide everything in half or put 50 grams of water instead of 100 grams of water? How much am I going to have? So you need to find out the ratio here. So with 100, it was actually divided by 2, and that's how they got 50. So you're going to divide this by 2, and you're going to get 41 grams. Okay, and that's your answer right there. You only need half the amount. This second question down here is talking about HCl. So it says 20 degrees Celsius for HCl. So you're going to go up to the line of saturation. So that's 20 degrees Celsius, HCl. So that's like 72. I'm going to put 72 grams at 100 grams of H2O. Okay? So they want to know, if I do 200 grams instead, how much am I going to need? So if you do 100 times 2, and that gives you 200, then you're going to multiply this by 2 as well. And you're going to get 144 grams. So this is going to be your answer. All right. I hope it helped. If you have any questions, feel free to reach out or comment below. And I will see you next time.